we have another problem where a, b, and c are integers. A squared minus b squared is 24. B squared minus c squared is 16. And we want to find the values of a, b, and c. The first thing we need to do is, well, in the strategy, we state that all numbers are in positive integers. So therefore, according to that logic, a is greater than b, is greater than c, is greater than or equal to 0. Now, let's solve this. So this b squared minus c squared is 16. That's just basically b plus c times b minus c according to algebraic formulas. So we also know that since we stated that they're positive integers, b plus c is greater than b minus c. Well, now we break 16 up. So 16 is 1, 16 and 1. There's also 8 and 2. And finally, there's 4 and 4. Now, we just have to test these values. Let's start with 16 and 1. B plus c is 16. So therefore, b minus c, that's a b minus c is 1. So when you add both of them together, you get that 2b is equal to 17. B is equal to 17 over 2. This one does not work because it asks for integers, and that's not an integer. Now, let's try 8 and 2. When b plus c is equal to 8, b minus c is equal to 2. When you add them together, 2b is equal to 10. So therefore, b is 5. Now, when you subtract them, you get that 2c is in fact 6. So therefore, c is 3. Now we can plug these values in. A squared minus b squared, which is 5. So 25 is 24. A squared is equal to 49. A is equal to 7. Now, we have a solution here that makes sense, but it's not all. A is 7, B is 5, C is 3. We stated that they're positive integers right here, but now it doesn't want positive integers, so therefore it can actually be plus or minus on. We solve for two possibilities. We just need to solve for the third to see if it works. We have one more possibility we need to go through. We use the same strategy. This time it's b plus c is 4. B minus c is 4. When you add them, so when you essentially add them together, we get that b plus c, I'll just write it out to visualize, plus b minus c is 8. Now we see that the c's cancels. 2b is 8. B is 4. Seems normal. Now let's try for the c's. When we subtract b plus c minus b minus c, that is 0. So therefore 2c is 0, c is 0. All seems to check out until this next part. A squared minus b squared, which is 4 squared or 16, is equal to 24. Therefore, a squared is equal to 40. So a is the square root of 40, which doesn't make sense at all. So the third solution also doesn't work. So our only solutions for a, b, and c is positive, negative 7, positive negative 5, and positive negative 3.